In this video, I'm going to focus more on subtopic 7.2, which is about chemical properties of haloalkane. So here are the learning outcomes for subtopic 7.2. Okay guys, so before I want to proceed further about the chemical reaction of haloalkane, I want you to look at the structure of haloalkane properly. Okay, so basically haloalkane ni ialah carbon yang directly attached to the halogen atom kan. Halogen atom ni is actually, for your information, is an electron withdrawing group. So bila dia electron withdrawing group, dia akan menyebabkan carbon ni less electron density, lower dia punya electron density. Dia akan menyebabkan carbon ni miskin. Therefore, this carbon is an electrophilic site. Do you remember back then when I told you electrophilic site pasangan dia ialah reagent yang apa? Electrophilic site pasangan dia ialah reagent yang nucleophile. Okay, nucleophile reagent. Since that pasangan electrophilic site ni ialah reagent nucleophile, therefore it will be a nucleophilic attack. Okay, if there is anything, it's going to be nucleophilic attack. So the type of chemical properties, or the main type of chemical properties untuk haloalkane is actually a nucleophilic substitution reaction. Okay, and also haloalkane is actually a polar compound. Okay, because kenapa? Because carbon is less electronegative compared to halogen. Halogen ni more electronegative, carbon less electronegative. Okay, tapi the other type of chemical properties of haloalkane ialah elimination reaction. This one I believe kita dah belajar dah dekat alkene. Okay, macam mana you nak prepare alkene, you buat dehydrohalogenation of haloalkane kan. Ni dah belajar dah. Benda yang kita akan belajar ialah nucleophilic substitution reaction and also the synthesis of Grignard reagent. Okay guys, there are three reactions in haloalkanes that you should know of. The first one is nucleophilic substitution, the second one is elimination, and the last one is the synthesis of Grignard reagent. Okay, nucleophilic substitution ni is the reaction between haloalkane plus nucleophile as the reagent, and then you will form, ada 5 jenis lah yang you boleh form. You boleh form alkohol, primary amine, ether, nitrile, ester. All of them you boleh form mereka melalui reagent yang sepatutnya lah. Okay, and then next one is elimination. I believe that you have met this before bila you nak buat alkene melalui proses dehydrohalogenation, where the reagent is potassium hydroxide and then ethanol, and the condition is reflux. Okay, you have met this before. Lastly is the synthesis of Grignard reagent, okay, ataupun the use of haloalkane melalui Grignard reagent, which from the Grignard reagent you can form alkene, alcohol, and carboxylic acid. Alright, so let's focus on the first type of chemical properties in haloalkane, which is about nucleophilic substitution. So nucleophilic substitution is actually a main reaction for haloalkanes. And basically you will substitute satu halogen atom bersama satu nucleophile. Okay, and there will be two types of nucleophiles, the strong and weak ones. Okay, kenapa you kena tahu the type of nucleophiles is because from the types of nucleophile you akan tahu apa jenis mechanism yang your haloalkane will undergo. Alright. Okay, so for example, this is the general reaction for the nucleophilic substitution of haloalkane. Kan ada 5 kan? Tapi tak kisahlah, walaupun ada 5, konsep dia sama saja. If you see this is your haloalkane and they react dengan nucleophile, what happen is this halogen atom will be the leaving group, so dia akan leave this haloalkane and then nucleophile ni akan masuk. So that's why the product will get R and then dengan nucleophile itself. Okay, sebab tu you boleh form alcohol, boleh form nitrile, okay, and so on. So the X ni akan jadi the leaving group. Okay, so apa yang berlaku bila let's say nak buat mechanism nanti, since that this is electrophilic site, this is a nucleophile reagent, so it's going to be a nucleophilic attack. at the electrophilic side. Okay, so you kena ingat tu lah. And then the bond akan break heterotically, and halogen will leave the haloalkane because halogen is a good leaving group. Okay guys, kenapa Miss cakap penting untuk kamu tahu the type of nucleophiles and also the class of your haloalkane is because dia akan menentukan the mechanism for nucleophilic substitution reaction in haloalkane. So there are two types of mechanisms in haloalkane. So the first one is SN1. The second one is SN2. What is SN1 dengan SN2? S stands for substitution, N stands for nucleophilic, and N ni kena kecil macam ni lah. 1 stands for unimolecular, ataupun bila react determinant step tu only involves one reactant. That's why nombor 1 tu dapat daripada situ. Okay, nombor 2 ni dapat daripada bimolecular because dia punya react determinant step ni akan involves 2 reactants. Okay, so kalau SN1, ciri-ciri yang akan undergo SN1 mechanism ini khas untuk nucleophilic substitution of haloalkane je, bukan elimination, bukan Grignard reagent, only for nucleophilic substitution of haloalkane. So kalau SN1 mechanism, it follows the first order reaction kinetics. Dia akan use weak nucleophile such as CH2O, CH3, CH2OH, NH3. If you see here, tak ada langsung metal kat sini kan. That's why the weak nucleophiles, and then dia akan favor tertiary haloalkane, but it can only favor secondary haloalkane kalau dia guna dengan weak nucleophile. Okay, macam secondary haloalkane ni actually dia depends pada the type of nucleophile. Okay, next ialah SN2 mechanism. SN2 mechanism dia akan follow second order reaction kinetics. Dia akan use strong nucleophiles such as OH minus, CH3O minus, CH3COO minus, Cn minus, NH2 minus. Okay, this nucleophiles, there is a strong nucleophile because actually before dia dapat charge negatif ni, dia berpasangan dengan metal tau. Contohnya macam metal in group 1 or group 2. Contohnya before this is actually NaOH ataupun KOH. This one pun mungkin before that it is CH3COONA. Ni pun mungkin previously is KCN. So bila dia berpasangan dengan metal, dia boleh terus break the bond. Jadi satu tu positif, K plus, satu lagi negatif. Nucleophile yang memang terus dapat negative charge instantly, itulah dia strong nucleophiles. Okay, and it will favor methyl halide and primary haloalkane. As usual, secondary haloalkane depends on the type of nucleophiles yang digunakan. Kalau let's say SN2 dia gunakan strong nucleophile. Okay, so here's the summary for the mechanism of nucleophilic substitution in haloalkane. Tak adalah summary in full details yet because this is something that you need to know je lah before kita nak buat mechanism for nucleophilic substitution in haloalkane for real. Yang ni just kamu nak kena familiar, get yourself familiar. Kita ada dua jenis mechanism in the nucleophilic substitution in haloalkane, which is SN1 dan juga SN2. Okay, kalau SN1, for now lah, for now dulu, Miss nak kamu tengok the type of nucleophile yang digunakan. Kalau weak nucleophile, dia akan buat SN1. Kalau dia strong nucleophile, dia akan buat SN2. Okay, yang order of reactivity ni pasal the class of haloalkane tu, it will come later. For now, Miss nak kamu fokus on the strength of nucleophile untuk tentukan the type of mechanism yang haloalkane kamu akan buat bila dia undergoes the nucleophilic substitution. Okay, so kita tahu nucleophilic substitution in haloalkane ada berapa tadi? Ada 5. There are 5 of them, right? So the one of it is formation of alcohol. So macam mana you nak form alcohol? You boleh form alcohol dengan menggunakan dua jenis nucleophile, the weak one or the strong one. But tak kisahlah, it doesn't matter you guna weak ataupun strong nucleophile. Regardless, you still get an alcohol over here. So basically, you will only just replace the halogen with OH. Okay? Cumanya kat sini, kamu kena kenal pasti, get yourself familiarized which one is a weak nucleophile, which one is a strong nucleophile. Kalau weak nucleophile, you kena tengok dia tak ada, one of the characteristic is dia tak ada metal, tak lekat dengan metal. Okay, dia tak lekat dengan metal. Tengok ni, HOH, H2O kan? Tak lekat dengan, tak ada metal langsung. So that's why it's a weak nucleophile. Kalau strong nucleophile, contohnya NaOH. Na is a metal group. This one is a metal group berapa? Group 1. Okay. So since that ada kehadiran metal kat situ, dia akan menjadikan this nucleophile is a strong nucleophile. So this OH akan terus dapat OH minus instantly. So bila dia dapat OH minus instantly, itulah menjadikan dia strong nucleophile. Tapi condition dua-dua tak kisahlah. Guna strong nucleophile ke weak nucleophile, the condition must be in reflux. Kena reflux ya, condition untuk buat nucleophilic substitution ni. In every nucleophilic substitution actually, condition dia semua reflux. Nucleophile je berbeza according to what kind of product yang you nak form. Kalau alkohol, you gunalah sama ada H2O ataupun NaOH ataupun KOH. Okay, KOH, is it a strong or weak nucleophile? KOH is a strong nucleophile. Kenapa dia strong nucleophile? Because K ni ialah metal group 1 kan? So sekarang ni I just want you to get familiarized dengan what type of mechanism yang dia akan undergo. Kalau let's say dia weak nucleophile, dia akan buat SN1 mechanism. Kalau dia strong nucleophile, dia akan buat SN2 mechanism. Okay, so let's look at this example, shall we? For example, you ada this kind of haloalkane. Okay, what kind of class of this haloalkane? This carbon is attached to 3 carbon atom. So, dia akan menjadikan this carbon atom ialah carbon tertiary. Therefore, this will be a tertiary haloalkane. And then look, dia berpasangan dengan weak nucleophile. Kalau weak nucleophile, dia akan buat SN1 mechanism. And also tertiary haloalkane pun dia favor SN1 mechanism. You kena ingat tu. Lepas tu, apa yang berlaku, dia akan buat nucleophilic substitution reaction kan. Therefore, dia akan replace, dia akan substitute Br dengan OH. Okay, nucleophile OH. Dia akan substitute this Br with OH. So that's why dia punya produk akan dapat alkohol. Tapi mekanisme dia jenis SN1 mechanism. Alright, next, if you look here, this is actually a primary haloalkane because this carbon is only attached to 1 carbon, right? So this is a primary haloalkane. Okay, so sekarang ni you tengok dia guna reagent NaOH. This is a metal. This is the nucleophile yang kita nak. So this is a strong nucleophile. And then the condition reflux, that means dia nak menghasilkan alkohol. Therefore, we will replace Br dengan nucleophile OH. Okay, so dia punya produk kita akan dapat alkohol. Ni side product masing-masing lah. Kalau side product untuk weak nucleophile dia extra sikit. Jadi H3O plus akan this Br akan jadi living group Br minus. Tapi kalau let's say dia buat dengan strong nucleophile, this Na akan terus melekat dengan Br because Na ni bila dia berpisah dengan OH jadi Na plus kan, OH minus. So Br ni bila jadi living group dia jadi Br minus. So Na ni akan bergabung dengan Br terus. That's why dia terus jadi NaBr. Tapi this OH akan tukar kedudukan dengan this Br. So jadilah dapatlah kamu primary alcohol. Okay, next up, macam mana kamu nak form primary amine if let's say you ada haloalkane? You boleh buat nucleophilic substitution with reagent NH3, ammonia. NH3 ni ammonia. Ammonia and then kena dalam alkohol ethanol. Tapi condition reflux. Okay, so apa yang berlaku kat sini? This X will be replaced by NH2. One of the H dekat NH3 ni akan bergabung dengan X ni lah once dia dah left this haloalkane. So that's why bukan NH3 lah yang dia masuk dekat sini. NH2. Okay, because why? Okay, Miss tunjukkan lah. Okay, so kalau let's say this is RX haloalkane pluskan dengan NH3 and dia memang patut kena ada 3 je covalent bond dan 1 lone pair. It's always like that. Tak boleh melebih-lebih. You bayangkan kalau NH3 ni I masuk kat sini kan. Macam for example lah. Kalau let's say this one 2 bergabung, I masukkan tepat-tepat NH3R, lepas tu I replace X dengan NH3 betul-betul NH3. So sekarang N ni dah ada 4 covalent bond. So dia tak boleh ni, nanti dia akan jadi ada plus sign kat sini. So tak stable. Therefore dia boleh masukkan NH2 saja. Dia kena kurangkan jumlah one of the H in NH3 ni supaya N ni dia dapat form only 3 covalent bond. Okay, 1 covalent bond ni dengan alkyl group kat sini. Okay, lagi 2 tu daripada diri dia sendirilah. So one of the H here, apa yang berlaku? One of the H here akan bergabung dengan X ni lah untuk form side product. Okay, NH3, N adalah nitrogen. So kalau nitrogen, is it a metal or non-metal? Nitrogen is a non-metal. So bila dia non-metal, dia bukanlah metal pun. Ni pun non-metal, dua-dua non-metal. So this will be a weak nucleophile. Kalau weak nucleophile, dia akan buat SN1 mechanism. Okay, you kena familiarize dengan the types of mechanism kalau dengan with respect to the strength of nucleophile dahulu. Nanti baru Miss akan go through further about the mechanism with you later. So, for example, if let's say you ada this kind of haloalkane, this is your alkyl group, this is your halogen. Okay, bila you nak buat nucleophilic substitution, you will always replace your halogen dengan nucleophile. This is your weak nucleophile. Tapi you tak adalah nak masukkan NH3 kat sini semua. You kena buang one of the H here. So kiranya dia akan replace Cl ni dengan nucleophile NH2. Okay. Tapi kena ada ethanol. Lepas tu condition reflux. So this is the primary amine. Kenapa dia primary amine? Because this N is only bond kepada satu sahaja carbon. That's why this will be a primary amine. Next up, from the nucleophilic substitution of haloalkane, you boleh form ether. Okay, sama ada melalui reaction with alcohol ataupun sodium alkoxide. Alcohol is a weak nucleophile because why? None of the punya compound ada metal. So it's a weak nucleophile. Tapi this is nucleophile dia lah. Alkyl yang ada O. This one will be the nucleophile because kenapa? We will replace the halogen dengan OR. R ni alkyl lah. Alkyl yang attach pada oksigen yang attach pada alkohol OH ni. Alright, next ialah sodium alkoxide. Sodium alkoxide is a strong nucleophile. Okay, this is alkoxy group because R prime ni ialah alkyl group lah. Okay, and then alkyl group kan always starts dengan carbon atom. So this is somehow dia macam CONA. Sebab tu dah nama dia sodium alkoxide. Okay, so basically this is a strong nucleophile because Na ni adalah metal. Tapi nucleophile yang akan replace the halogen ialah OR prime. Okay, so this dua-dua ni ialah ether. Okay, tapi you gunakan nucleophile yang berbeza. Okay, kalau you gunakan weak nucleophile, you akan buat SN1 mechanism. Kalau you guna strong nucleophile, you akan buat SN2 mechanism. But then dia punya product sama je, but the side products will be different. Kalau side product untuk alkohol ni, kamu akan dapat hydrogen halogen. Kalau side product untuk strong nucleophile ni, you akan terus dapat you punya metal campurkan dengan you punya halogen. Okay, for example, if we have this haloalkane, so what is the class for this haloalkane, guys? So if you look here, this carbon yang you kena pay attention because this carbon yang attached pada halogen and this carbon is actually bond kepada another 2 carbon atoms. Okay, you kena ingat kalau cyclic compound kena hati-hati, you kena bawa keluar dia punya carbon tu. So this will be carbon primary ke secondary ke tertiary? carbon secondary. So since that this is secondary carbon, therefore it will be a secondary haloalkane. Okay, kalau secondary haloalkane, if you want to know the type of mechanism yang dia undergoes, you need to tengok the strength of nucleophile. If let's say dia guna weak nucleophile, like this is a weak nucleophile because this is alcohol. Inilah your R. Okay, this is actually R. R prime yang before this dekat previous slide kan, this is your alkyl. Okay, tapi kalau nak ikutkan as a nucleophile, you need to focus on CH3 CH2O lah. Okay, so what happened here, this weak nucleophile CH3 CH2O akan replace Br in a way that bila Br ni dia left this haloalkane, O ni akan directly attach pada carbon yang dahulunya carbon tu attach dengan halogen. Okay, so Miss highlightkan, this is the carbon yang attach pada halogen previously, but then after dia buat nucleophilic substitution dengan this weak nucleophile untuk form ether, so this carbon akan terus directly attach pada oxygen O and then CH2, CH3, and you need to remember CH3 kena always kat belakang sekali, alright? So this is alkoholysis reaction actually. Okay, alkoholysis reaction between weak nucleophile. Kalau digunakan weak nucleophile, dia akan promotes SN1 mechanism. Dia akan buat SN1 mechanism kalau let's say dia nak kena buat mechanism lah. Okay, and then for secondary or tertiary haloalkane memang always favor SN1 mechanism anyway. Okay, next let's look here. Okay, this carbon pun is actually a secondary haloalkane, isn't it? Because this carbon is bonded to another 2 carbon atoms. So this carbon will be a secondary haloalkane. Okay, kalau secondary haloalkane, if you want to know the type of mechanism yang dia buat, it will highly depends on the strength of nucleophile. If you look at here, the type of nucleophile yang digunakan ialah strong nucleophile because ada kehadiran metal kat sini. Alright, so this whole thing will be the nucleophile. Start daripada O, CH2, CH3. Okay, this is the strong nucleophile that akan gantikan Br. Okay, yang akan replace kedudukan Br. So, apa yang berlaku? This carbon, instead of nanti dia attach dengan Br, after dia buat nucleophilic substitution, dia akan terus attach dengan CH2, CH3, O, CH2, CH3, okay? Alright, so since that dia gunakan strong nucleophile, so dia akan buat SN2 mechanism. Alright, so as usual, methyl, primary and secondary haloalkane actually favor SN2 mechanism. Okay guys, so how can we form nitrile compound daripada haloalkane? Nitrile compound ni is basically a C triple bond N yang attach pada alkyl group. Okay, so basically kita kena gunakan strong nucleophile such as KCN. How do you know that this is a strong nucleophile? Because nucleophile Cn- ni dia buat ionic bond dengan K+. K+ is a metal ion. Alright, so nanti Cn- ni hanya replacekan saja kedudukan halogen and nanti dapatlah nitrile compound. Okay, and the condition must be reflux. Since that dia guna strong nucleophile, therefore dia akan undergoes SN2 mechanism. Tapi nitrile compound ni dia boleh react further. Okay, dia boleh react further, dia boleh buat reduction with reducing reagent such as follows, and dia akan dapat primary amine. Okay, kalau let's say dia buat hydrolysis with this kind of reagent, dia akan dapat carboxylic acid. Actually, kalau let's say you nak tambah carbon, contohnya you nak buat synthesis of organic compounds kan, daripada tiba-tiba ada 2 carbon, kat belakang tu ada 3 carbon. So you kena undergo nucleophilic substitution, you kena buat nitrile because this is a useful reaction untuk increase the number of carbon atoms. Okay, kalau tak percaya, let's check it out the examples nanti. So for the first example, you have CH3, CH2Cl. So basically bila you reactkan dengan strong nucleophile such as Cn-, ni dah macam terlampau simple sangat ni. Dia bagi Cn-. And then condition reflux, kamu akan terus dapat CH3, CH2Cn. Bertambah tak carbon dia? Bertambahlah. Daripada ada 2 sahaja carbon, now dia ada 3 carbon. 1, 2, 3. Cuma dia ada N kat belakang ni. Tapi dia bertambahlah carbon dia. Okay, and next, if you look here, you have CH3CH, CH3Br plus KCN. You know that this is actually a strong nucleophile, tapi nucleophile yang akan digunakan ialah Cn-. So basically you replace sahaja kedudukan Br dengan Cn. So now dah bertambahkan carbon daripada 1, 2, 3 carbon jadi 4 carbon. Okay, that's why it's a useful reaction untuk buat pertambahan carbon. Okay, so next, this is a nitrile compound. This is a reducing reagent. Therefore, dia akan terus form primary amine. So C ni, bila dia reducing reagent, dekat each of this carbon dan nitrogen, each of them akan terima 2 hydrogen atom. So you tengoklah ni, C ni dapat 2 hydrogen atom, N dapat 2 hydrogen atom. Itulah dia reducing reagent. That is what reduction does to the nitrile compound. Next, kalau you buat hydrolysis of this nitrile compound, what will happen is N ni akan completely gone and C ni akan terus dapat double bond O, OH. Okay, that's how nitrile compound punya process. Alright, lastly is the formation of ester from haloalkane. Macam mana kamu nak form ester daripada haloalkane? You kena gunakan strong nucleophile such as alkyl yang ada COO, Na, yang ada sodium. Okay, so you know that this is a strong nucleophile because ada kehadiran sodium atom, which is this is metal, and with the condition reflux, so you will get your ester. Since that you use a strong nucleophile, so it will undergo SN2 mechanism. For example, if let's say you ada this kind of haloalkane, so what is the class for this haloalkane? This carbon is only attached to only one carbon, therefore this will be a primary haloalkane. Okay, and then dia guna dengan strong nucleophile such as CH3 COO Na. So what happened here, we will replace this Br dengan CH3 COO. Okay, we will replace this with CH3 COO where kita akan lekatkan. Okay, kalau let's say previously we have this carbon yang directly attached pada halogen. Okay, so what happened is after that terus akan dapat terus lekat dengan O tau. Lekatkan dengan O, lepas tu another O, C. Itulah nama dia COO and then CH3. Okay, so kalau let's say if let's say I tulis dalam bentuk condensed, it will be OOC CH3. Okay,